Hello, and welcome to my 2022 Undergraduate Scholarly Showcase presentation. My name is Grace Goodhart, and today we will be looking at how sugar consumption in Aedes aegypti and Culex pipiens female mosquitoes impacts their humidity preferences. Mosquitoes are pesky insects that are vectors for numerous deadly diseases, affecting most, if not all, of the world's population. Given that these insects have such a widespread impact, it is critical that we understand their behaviors. One such behavior is humidity detection. Female mosquitoes use humidity detection to find water and hosts for egg laying and blood feeding. Also, it is well known that sugar plays a critical role in the proper functioning of many mosquito behaviors, such as flight, egg laying, and survival. However, high sugar diets may be harmful to an organism. For instance, high sugar diets disrupt the immune systems of Drosophila. So, exploring how sugar impacts humidity detection may provide an excellent opportunity to control mosquito behaviors to limit disease transmission. Three types of sugar were used in this study: sucrose, arabinose, and sorbitol. Sucrose is common table sugar and likely what you use in your morning coffee. While some types of sucrose are commercialized, it also occurs naturally in plants. Arabinose has the same level of sweetness as sucrose but lacks nutrition. Sorbitol has reduced sweetness compared to sucrose but retains its nutritional value. 7 sugar treatments were created using these sugars, including a 10% sucrose with water control group. By comparing the behavior of mosquitoes under these conditions, we can understand what may be influencing their preferences. For the experiment, both Aedes and Culex were provided one of the 7 sugar treatments for 5 days. After 5 days, 25 to 30 female mosquitoes were collected using an entomology aspirator and placed in the experimental cage. Within the cage were 2 jars covered with a cup in the hole at the bottom to allow mosquitoes to enter the jars. Within each jar was a smaller container filled with either distilled water or a supersaturated saltwater solution to represent 100% or 75% relative humidity, respectively. After 24 hours in the experimental cage, the number of mosquitoes inside the jars were recorded according to their preference, while the mosquitoes that remained outside the jar were denoted no choice. The data was used to calculate avidity and behavioral preference indices for each treatment and species. Avidity refers to the preference for either of the humidity jars compared to no choice, calculated as the percentage of mosquitoes in the jars compared to the percentage outside the jars. To compare humidity preferences between the two relative humidity jars, behavioral preference indices were calculated using this formula. Multiple t-tests were conducted to compare the avidities and behavioral preference indices of the 6 sugar treatments compared to the control for each species. Here are the avidity results for both species. The bars represent the average percentage of mosquitoes collected from the jars according to sugar treatment. For Aedes avidity, all sugar treatments besides the 10% sorbitol with water treatment were significant, meaning the average percentage of mosquitoes in the jars under these conditions was different enough from that of the control to be considered statistically significant. Comparatively, the Culex avidity results show that only the 30% sucrose and 10% sorbitol with water were significant. So what does this mean? Since the Aedes female avidity was affected under more treatment groups, the avidity data shows a species-specific pattern. Here are the results for the behavioral PIs. The bars represent the calculated PIs, showing the mosquito's preference for the 100% humidity jar over the 75%. The PIT tests showed that for Aedes, the 30% sucrose only, 10% arabinose with water, and 10% sorbitol only conditions were significant. Comparatively, none of the sugar treatments were significant for Culex. The behavioral PI's results were similar to the avidity results in that they were species specific. Aedes humidity preferences were significant under more treatments than what was observed by Culex. These patterns have important implications for the control of mosquito life cycles and subsequent control of the spread of pathogens. Mosquitoes could be provided with specific sugar treatments that limit their ability to reproduce and find hosts, thus reducing the number of people exposed to mosquitoes and related diseases. Future studies can aim to replicate these results and explore different concentrations and types of sugar treatments. I would like to thank the members of the Benoit Laboratory, especially Dr. Shiki Chen and Dr. Joshua Benoit, for all their help and guidance on this project. Thanks for listening.